This video is a continuation on the previous video on working with inequalities in two variables and their associated graphs. Now these two next examples are going to talk about looking at a graph and trying to come up with the inequality that represents the graph. So right now we have this situation going on where we have a graph of an inequality and we're trying to come up with the actual inequality statement. Two things that I should see right now. This part is the shaded region. So that's my solution region. All my infinite number of solutions are in there. The other thing we see is this boundary line. This boundary line is dividing it into the solution region and the parts that aren't the solution. And we should see that this is a dotted line. So this being a dotted line means that this is either a greater than or a less than inequality because the line is not included in the solution. And we have to look at where the shading is. The shading is actually happening below the line, which means this is a less than inequality. So we're going to have to come up with an inequality that actually includes the less than symbol. First thing we need to do is get the equation of the line. Now this is a skill that you did a lot of in grade 10. So we're going to go back to this equation that we looked at in our previous lesson, y equals mx plus b. Since this is a linear function, basically a straight line, we should be able to figure out its slope and its y-intercept. So right from here, this represents the y-intercept. And if I look closely on the graph and I try to include these points, right here is my y-intercept. The coordinates of that point are 0, -2. That means that this b value is going to equal -2. The m, we talked yesterday, talks about the slope of the line. So for the slope of the line, we could count the slope, but I'm going to use this opportunity to actually review our slope formula from last year as well. The slope formula that you looked at last year was slope is the difference of the y's over top of the difference of the x's, of the two coordinates from the graph. So I can look, here's another point on the graph. This point right here is -1, 0. So I have 2 points that I can use to find the slope of this graph. Now it says take your y's and subtract them. So here are my y coordinates. So I'm going to subtract them. I'm going to say 0, take away -2. And then it says divide that by the x coordinates subtracted in the same order. So now that's -1 take away 0. So if I simplify this fraction or this slope statement, 0 minus -2 is a +2. -1 minus 0 is -1, which means the slope of this line is -2. So to work with the equation of the line now, we can just simply say the equation of this line is y equals -2x minus 2. So this is the equation of the boundary line that we have. And if we look and we talk about what we had said right at the beginning of this video, this is shading below, so this has to be a less than inequality. So if this is the equation of the line, y -2x minus 2, we're saying we're shading everything less than that line. This is the second part to that question. This is the actual inequality that represents the graph shown. So we had to find the boundary line, the equation of it, that's y equals mx plus b, and we had to actually determine if we're shading above or below, and if that boundary line is included. Since it's a dotted line, it is not included in the solution, and we just say less than. So let's complete another example with the same sort of information. Write an inequality to represent the following graph. So again, a few things we can see. We can see the shaded region. The shaded region is above the line, so that means we're going to be talking about a greater than inequality because it's above the line. And the line is solid, so the line is part of the solution region, which means this is greater than or equal to. So my final inequality will have that. So again, we need to work with the slope y-intercept form of this graph. Y equals mx plus b. The b value, again, we can see is just our y-intercept. And our y-intercept is telling us is at 5. So b is going to be a positive 5. My slope, we're going to work with that equation again. The slope is the y's subtracted over the x's subtracted in the same order, rise over run. So if I look at my graph, it identifies 2 points for me. I'm going to look at my y's first. I have a 5 and a negative 10. So that's 5 minus negative 10. Now I look at my x's. 0 minus negative 20. So 0 minus negative 20. We can simplify this fraction. 5 minus negative 10 is a positive 15. And then 0, take away negative 20, is a positive 20, which tells me I have a slope that is, in lowest terms, a positive 3/4. And the line is going up to the right, so from grade 10, you should identify that as a positive slope. So then the equation of our boundary line, being mx plus b, is y equals 3/4 x plus the y-intercept of 5. That's the equation of the boundary line. But this is an inequality, which is shown by the shaded region, and we already determined that greater than or equal to is the inequality we're looking at. So we just talked about our inequality being y is greater than or equal to 3/4 x plus 5. It's greater than because we've shaded above the line, and it's or equal to because the line is solid, which means any point on that line would also make this inequality true. So that's how we find the inequalities given a picture of its graph. We have to consider the equation of the boundary line, whether the boundary line is included in the solution region or not, and if we shaded above or below that boundary line.